Hi everyone, this is Kareem from Mathemagic. So are you ready to do some math? Alright, so today I've titled this video Learn Mathanese. Now what does that mean? Well, Mathanese is what I like to call a language, and it's the language of mathematics. So you don't need to think that math is so complicated, because the great thing about mathematics is that in any language, whether you speak Russian or Chinese or Indian or French or any of the languages that you could think about, we use the same symbols in mathematics so that mathematicians can understand themselves through mathanese. And so I'll run through some basic symbols that we use so that you can understand how this applies to you speaking mathanese yourself. You can use this in coding as well, and it's important that you understand all these different symbols so that you're able to write mathematics properly, and that you can explain your argument without using too many English words, but you can actually learn the simple symbols that are going to help you to learn a little bit faster. So let's get started. So these are your very basic operators. Division, I think we know that. Now the cool thing about division is it looks like a fraction symbol, and when you think about it, it is it's a fraction. A fraction is a division that hasn't happened yet. So there you go. Multiplication, which is multiplying two numbers together. Addition, subtraction, I think these are fairly self-explanatory. Equal, which originally was the idea that one mathematician wrote, nothing can be more equal than two parallel lines. And so before that, we used to write a long sentence to say this thing is equal to that thing, but now we just write two little lines like that. If you write three lines, it means is identical to. So I didn't put that in here, but that's important as well. So the crossed out parallel lines is it's not equal to, and when you kind of round a result at the end of a calculation that is not exactly the same, you should say is approximately equal to, so that it doesn't look like you're saying it's equal when it's not really equal. So let's carry on. Okay, so the crocodile points to the number that is bigger, so is less than. And then you have the crocodile with the equal sign, which means is less than or equal to. So if it could be equal to the number, then you say less than or equal to. So if you say something is smaller than equal to 3, it can be equal to 3. If you say less than 3, it's strictly less than 3, so 3 is not included. And then you've also got is greater than or equal to. Then you've got your snowman, or your sideways 8, which is infinity. So that's the biggest idea you can think about, so bigger than the biggest number in all of your dreams. An arrow pointing to one side saying a statement implies another statement, so this is a logic symbol. And then the other way around, say is implied by, so your first statement is implied by the second one. And then the two-way statement saying implies by and is implied by, so saying that both mean that the other statement is correct, so the converse is also correct. I'll give you an example. Pythagoras' theorem means that a triangle is right angle. Like if you can prove that Pythagoras' theorem works, then the triangle is right angled. If you have a right angled triangle, then Pythagoras' theorem will work. So that's implies by and is implied by. That's a two-way statement. Because, so that's the three little dots, but which are pointing downwards, so a little downwards triangle, or since. So you can say this is happening because of this. So you explain that the reason why it's happening is because of something else. And then therefore is to have flow in your arguments. You say, I've found this result, therefore, and then you can write your next line to say, this is my next argument. These are pretty advanced and a little bit more interesting, I guess. So the big E says there exists. So maybe you find something that proves that somewhere along the line there exists a value. For example, if you're talking about high-level mathematics and you've got a curve which crosses a line, if the curve is continuous, like if it doesn't stop and there's a line in the middle, and then a part of your curve is negative and a part of your curve is positive, well, there must exist a point in between where it crosses the line. So you would use that in a statement like that. Belongs to, so your little euro sign, well actually this one is written as does not belong to, so I've swapped them around. Oh, I made a boo-boo. So belongs to is the euro sign, which I wrote as does not belong to, and then the one where you cross it out means does not belong to. Okay, so when you cross it out, it means it doesn't belong to, and then when you don't cross it out, it means it does belong to. Infinity, we've already been over it. The square root sign, so the radical symbol is square root. The cube root sign is the square root symbol with a little 3 inside. And if you put a 4, it means the fourth root, so these can go on. And then the Greek letter sigma means the sum. So when you're trying to add several things, so you say like the sum of a sequence, for example, you'll use the symbol sigma for sum. When you talk about number sets, you can talk about the intersection. So the intersection of two number sets is what they have in common. So if I have a bunch of toys and you have a bunch of toys, but you have a brown teddy bear and I have the same brown teddy bear, we both have it. So that's the intersection of all your toys and all of my toys. The union of all your toys and all of my toys are all of our toys together. So it means we're counting all of your toys and all of my toys, including the brown teddy bear and including any other toys that I have in my room or that you might have in your room. So the intersection is what we have in common, and then the union is everybody holding hands together. It's all the items together. And then we have this kind of V here with the line through the middle. That means for all. For all the values. So that's something like an opening statement. So all the values, for all the values in the real numbers, and then perhaps there's a statement, but essentially that's what it means. It means for all. The squiggly bracket means set of numbers. So that's a number set. And then the forward slash means such that. Now, I've recorded another video on number sets specifically, the natural numbers, the integers, and so on. So I'm not going to go over this in this video. I recommend that you go and watch the video on what number sets are if you'd like to know more about this. But the big letters at the bottom, you have the natural numbers, you have the integers. So natural numbers are whole numbers, positive. The integers are positive and negative whole numbers. Q, which is the rational numbers, so numbers that you can express as fractions. And then you'll have R, which are the real numbers, all the numbers you know. And C, the complex numbers, which if you study high level mathematics, you'll encounter as well. They can be represented on what we call the Argand diagram. So I hope this is useful to you and that you understand mathanese a little bit better. Make sure to like and subscribe to our channel, and I'll see you in the next one. Thank you so much.